This is lesson 1 in chapter 4, representing relationships. First thing that I would like you to do is begin your gold sheet today. It is mandatory you start your gold sheet today. I will be checking on this. The first thing that should be on your gold sheet is a definition of linear equation. You should already know quite well what linear equation means, but the key phrase here is straight line. If we can graph an equation and it forms a straight line, it is indeed linear. Pretty simple concept. Okay, sample number 1. We have a table that shows the number of liters, L, in quarts of liquid, Q. So remember that we will regard this as our input and this as our output. Normally we would call this X and this Y, but in this case I think it's really intelligent to use L and Q, because then we can immediately see that we're talking about quarts in one case and liters in the other. And number 1 asks us to write an equation to find the number of liters in any number of quarts. Describe the relationship in words. So first of all, what we need to do is take a look at finding the rate of change. Now the way they do it is they use these as points, and they say 1.9 minus 0.95, change in y, that would be right here, over 2 minus 1. So this is y2 minus y1 over x2 minus x1. And we get 0.95 over 1, or 0.95 liters in every quart. So when we describe that relationship in words, we would say that we have 0.95 liters in every quart. Now another way that you could do this problem that I want you to be aware of is they've already done this part for us here, where we're seeing that we have a rise of 0.95. We could also take a look at this over here, see that we have a rise of 1, and we could just look at it this way: the change in y over the change in x. The change in y is 0.95, 95 100ths. The change in x is 1. So again, we have 0.95 is our slope. So for our equation, normally we'd say that y equals the slope times the x value plus the y-intercept. Well, first of all, we can look back and find our y-intercept. If instead of adding 0.95, 95 100ths, we subtract it, we'll end up back here at 0. And if instead of adding 1 over here, we subtract 1, we will end up at 0 here. So we know that the b is going to be 0. We'll write it here just so that we have it in our equation. Our y is our output. So we have liters equals our slope, which we said was 0.95, 95 100ths. And our x value in this case is our input, which is Q. So here's our equation. Liters equals 95 100ths of quarts plus 0. And obviously we would not actually put this in our equation. We would just have liters equals 0.95 Q, just like they have right here. Now let's take a look at problem number 2. In problem number 2, they say about how many liters are in 8 quarts. So we had the equation liters equals 95 100ths of quarts. And they gave us this for quarts, so we're just going to show liters equals 95 100ths times our 8 quarts. Take out a calculator and we'll see that that is there are about 7.6 or 7 6/10 liters in 8 quarts. Please press pause and do letters A and B. In this case, I would recommend using the letters T and C for your input and output values. Example number 3 says the total distance Marlon ran in 1 week is shown in the graph. So you can see all the values for the distances that he ran on the graph. And it asks us to write an equation to find the number of miles run, y, after any number of days, x. So what they suggest we do is that we find the rate of change using point-point form. So we're going to take the second point minus the first point, change in y over change in x, and get a slope. So let's take a look at that first. again, all they do is they did y2 minus y1 over x2 minus x1. Unfortunately, we can't see those values here, but you can plainly see them in your book. So we had 14 minus 7, so we have 7, and 4 minus 2 gives us 2, so we have 7 over 2. We would simplify that in this case because we want a unit rate of 3.5. Now let's go back and take a look at doing that a little bit differently. We could come up here, and again, what we're looking for is the change in y over the change in x. Well, we can look at this and look at any number of points. I'm going to take these two here because they're quite easy. The change in y, well, if we're at the 7 value here on y and we move up to the 10.5 or the 10.5 value, we can clearly see that the change in y is 3.5. And then we look at the change in x. We rise from 2 up to 3. That is a plus 1. This also back here was a plus 3.5. Don't forget about your sign. So now we're looking at the change in x was 1, and we have the same slope they have. So now we know that the slope is 3.5. The next thing we need to do is look for the y-intercept, because then we can put this in the format of y equals the slope times the x value plus the y-intercept. Again, if we look back over here, we can recognize, let's get rid of all of this, we can recognize that from 17.5 down to 14 is a drop of 3.5. Now technically this isn't a drop, this is a rise, but we're going in reverse, so we can just keep going down. We have 17.5, we're subtracting 3.5, so if we go from here down to the next point, we would subtract 3.5, so we would be at 0 for our y value. Here we can see that we've got 5, 4, 3, 2, 1. The next point obviously would be 0. The point I'm making here is that we can show that this is indeed a nice straight line, which we can show with our arrow here, arrow through, and you can see that these points go right through the origin. So we have a y-intercept of 0, 0. Now let's take a look at the way they did this problem down here. So again, they used the definition of slope to find the slope, which we agreed the slope was 3.5. And then they said find the y-intercept, use the slope and the coordinates of any point to write the equation in slope-intercept form. So they used their slope of 3.5, and then they used the points 7 and 2, which if you look above in your book, you'll see that that was one of the points. Do the multiplication, and we have 7 equals 3.5 times 2, so 7 equals 7 plus b. And obviously, therefore, b must be 0, which is what we did. Two different ways to find the slope and the y-intercept. Use the way that works well for you. So now once we have that, we can write our equation as y equals slope, which was 3.5, times x. And it's plus 0, so we're just going to leave it as y equals 3.5x. Now our question is, how many miles will Marlon run after 2 weeks? Okay, so we have y equals 3.5x, and we're given an x value of 2 weeks, but we have to be careful here and recognize that 2 weeks is 14 days. So we're going to multiply 3.5 times 14, and we're going to do that in our head here in a minute if you're patient with me. The way you can do this in your head is really quite simple. You can double the 3.5. I think most of you could do that in your head. That's 7. And since we're multiplying, if we double one of the values, we have to cut the other value in half. So it's 7 times 7, which of course is 49. So Marlon can run 49 miles in 14 days or 2 weeks. Please press pause and do letters C and D. Okay, the next thing we need to do is put this concept on your gold sheet. This is something that I believe you're already quite familiar with because we talked about this multiple times in class. What we need to recognize is that we can show linear equations, linear relationships, equations of a line, y equals 3x plus 14, etc. Those types of things. We can put that in words. We can say something like this: distance traveled is equal to 12 miles per second times the number of seconds. We can put it in an equation like this, or like the one I just wrote here. We can put the data in a table, and we of course can put it in a graph. Again, like I said multiple times when I'm teaching up at the front board, each of these things could, if we have a graph like this, we can turn this into an equation, we can turn it into a table, or we could even put it in words if we'd like to. So all four ways can represent the same thing, and that's a very important concept. Okay, let's take a look at problem number 5. Write an equation to find the number of jumps in any number of minutes. Let J represent the number of jumps and M represent the number of minutes. Again, this is one of those cases where I would highly recommend that instead of using X and Y like I oftentimes say, use letters that kind of stand for what you're talking about. J for jumps, M for minutes, so that it makes more sense. So in this equation we would say J, the jumps, is equal to 225 times the minutes that we've been jumping. So now it says make a table to find the number of jumps in 1, 2, 3, 4, or 5 minutes. So we start out with our minutes. This again is going to be our input, and then we write our algebraic expression. In this case it's 225 times M, and then we're going to have our output here is going to be in jumps. Okay, so we have an input of 1 minute. So we're going to do 225 times 1 and get an output of 225. Then we're going to do 2, it's 225 times 2, 450, and you can see, etc. And you can see here that we're going to rise by 225. It's a plus 225 from point to point. Let's back that out of there. And then it asks us to graph the ordered pairs. So when we're graphing the ordered pairs here, we would have the ordered pair of 1 and 225. So on the x-axis, because that's our input, we have minutes of 1 minute, and at 1 minute we're going to be at 225 jumps. At 2 minutes we're going to be at 450 jumps. So at 2 minutes we're going to be at 450, and we can plot each of these points just as they asked us to. Please press pause and do letters E and F for Paul earns $7.50 an hour working at a grocery store. Make sure you use the letters that they ask you to use. M for money and H for hours. Make sure you label your axes here and here. Remember, here should be your input. This is going to be your output. And this right here would be your algebraic expression. You're going to put those in these 3 boxes here, and then put your 5, 6, 7, 8 here.